Oh, hi there, everyone. Thank you for all showing up for your learning. To get set up for today, please get out the handout from yesterday. If you somehow lost it between yesterday and today, I'd anticipated that some but not all of you would be in that situation, so I copied out extra copies there. That speaks to your responsibility as a learner. You want to take notes and accumulate those notes in some safe place so that you can refer to them in the future. But here I am, I'll help you out regardless. Okay, so I'm going to give you a moment to get set up and then we'll start with our lesson. All right, let's go. So here we go. If we want to complete a chart like this, well, we better know how to analyze a quadratic function. So I would suggest you get some blank paper out. I've got my blank digital paper here to analyze these functions. And that's where I'm going to be doing my rough work. So let's see. If I've got a quadratic like y is equal to negative 1 over 4 x squared plus 2x minus 3, and you told me you wanted to know where the vertex was. Let's get a pen on this page too. And you want to know where the vertex is. Well, our strategy is going to be we're going to make a little chart. A equals negative 1 over 4. Extract your numbers. B is equal to 2. And C is equal to negative 3. So this little chart is going to help us analyze this quadratic function. The vertex, the x value, is always at negative b over 2a. So let's evaluate this for this case. Negative b will be negative this number. This is a little recipe, and we just follow the recipe. So we have negative 2 there, substituting in for b, all over 2 multiplied by a, which is negative 1 over 4. All right? And so why did I put that little extra bit in there? That's annoying. There. All right. So now we evaluate. Negative 2 over 2 times negative a quarter. Well, I'll do 2 times negative a quarter, and that's going to be negative 1/2. So negative 2 over negative 1/2. 2 divided by 1/2 is 4, and negative divided by a negative is a positive. So this is equal to 4. X is equal to 4. So what's that telling me? That the axis of symmetry, x is equal to 4 in this case. So you find this bit out first, then you're going to go ahead and evaluate the maximum value of the parabola. Basically, what's forming in my mind here is a little picture of this. I have the x and the y plane, and I have over here at x is equal to 4, the axis of symmetry. Now I need to find the maximum value of this parabola. So let's input. So you're going to go ahead and maximize your paper. And we're going to take this function here, y is equal to negative 1/4, but I'm going to substitute in for x the value 4, plus 2, and then substitute in for x the value 4. Oops, I made a mistake. That should be x squared. Notice I forgot to square that 4 there, so make sure that's there. And then minus 3. So now I'm taking what this little trick tells me. This is the axis of symmetry. That's the x value of the vertex. Let's find out the y value of the vertex. It's equal to negative 1/4. 4 squared is 16. So negative a quarter of 16 plus 2 times 4, which is 8, minus 3. Negative a quarter of 16 is negative 4. Your calculator will tell you the same thing. Plus 8 minus 3 is plus 5. So the y value is equal to 1. Okay? So now we can put that in for the maximum value. The maximum value is y is equal to 1 for this parabola. Now we know the vertex. Now we know where this is. It happens to be at the point 4, 1. And I can put that on the little picture that's forming in my head. It's about there. 4, 1. All right. And now, the y-intercept. Well, what's the y-intercept going to be? Well, that one is pretty easy to find. It's just this number c. It's just this number right here. So, go ahead and put that one down. The y-intercept is going to be 0 minus 3. All right? So now this picture in my head is getting clearer. The y-intercept is down here somewhere at -3. I now know that this parabola looks like this. It rises until it gets to 4, and then it goes down again. Okay. The x-intercepts, well, let's find those. I don't know what they are, but I know the quadratic formula can tell me. So let's use the quadratic formula with this a, b, and c. All right, maximize your paper. Write out the quadratic formula. X is equal to, sing the song, negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so I've got the quadratic formula here. I'm just going to feed it my numbers. The quadratic formula is just a recipe to tell you x-intercepts. So feed it the proper ingredients and it will output what you're looking for. So in this case, b is 2, so negative b is negative 2. Plus or minus is plus or minus. The square root is something your calculator will tell you. B squared, well, I want 2 squared there. Minus 4 multiplied by a. A is negative 1/4, so put in negative 1/4 there. And then c is negative 3, so put in negative 3. Remember, you're multiplying, not subtracting. So substitute into brackets whenever you have a situation like that. All divided by 2a. Well, a was negative 1/4, so you have 2 multiplied by negative 1/4. So this is, again, just an example of substitute in carefully. Substitute into brackets and then evaluate carefully using bedness. So let's go. Oh, I'm running out of space. Just going to zoom, help you out with your note. Here we go. This is equal to negative 2 plus or minus the square root of 2 squared is 4. Negative 4 times negative 1/4 is 1. Your calculator will tell you the same thing. So that's 1 times negative 3. So 1 times negative 3 is negative 3. So that's 4 minus 3. All over 2 times negative 1/4. Yeah, that's 1/2. 1 over 2. All right. Let's evaluate now. 4 minus 3 is, well, this is equal to negative 2 plus or minus the square root of 1. Square root of 1 is 1. So it's just negative 2 plus or minus 1 all over 1/2. This gives us two possibilities. Negative 2 plus 1. This could be equal to negative 1 over 1/2. Or negative 2 minus 1. Well, that's negative 3 over 1/2. And let's evaluate. When you have negative 1 divided by 1/2, I feel like I missed a negative. Oh, yes, I'm missing a negative. There it is. Look, I have a negative there. And I forgot it 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 there. Did anyone see me getting progressively more and more uncomfortable as I worked with this negative that was missing in my work? The reason I was getting progressively more and more uncomfortable is because I have a visualization of this quadratic that looks like that. And it was telling me my roots were both negative. And I knew that couldn't be. I want them to be positive because of my visualization. Look, it crosses the x-axis at those 2 points. So all semester I've been saying visualize these things, see them in your mind. And I can't make you do that. I can't grab you by the arm and put your arm behind your back and take your thumb and twist it at an awkward angle because I'm not allowed to do that. I don't want to do that either. I'm just saying no one can make you do stuff in your head. But I can suggest strongly that you develop this ability to see things in your head. And as you do that, you develop this ability to, find your errors and things like that. So let's go on. If I have negative 1 divided by negative 1/2, that's the same thing as 1 divided by 1/2. The negatives cancel out. If I say how many halves are in 1, that's 2. Okay. The reason is if I'm dividing by a fraction like this, it's the same thing as flipping that fraction and multiplying it by the top. 1 times 2 over 1 is just 2. Okay. This is equal to, over here, 3 over 1/2, which is equal to 3 times 2, which is 6. So 2 and 6 are my x values of the zeros. So now I can go ahead and put that in my chart as well. So my x-intercepts here are 2 and 6. So I would write them this way: 2, 0, and 6, 0. And this shouldn't surprise me very much because I notice that they're symmetrical around this line x equals 4. They're both separated from that line x equals 4 by the same distance. So that looks good. The roots will always be symmetrical around the vertex. Okay, then we're also going to want to know things like, when is this quadratic increasing? When is it growing bigger? And you'll also want to know, for some other questions, the decreasing interval. When is it getting smaller? So if we take a look at our visualization again, you see this thing in your mind. It looks something like this. And I notice this parabola is getting bigger until it gets to the vertex. After the vertex, it's getting smaller. It's a little bit like someone's ready to catch. Kendall's ready. Oh yeah, so yeah, Will's ready. All right, Will's on the football team. So this eraser rises until it falls. It has an increasing interval and then a decreasing interval. And the vertex is what separates the increasing interval from the decreasing interval. So the increasing interval here is all values of x that are less than 4. So I would say here, x is less than 4. That's the interval where this parabola is increasing. Once it gets to the vertex, it starts decreasing after that. And then I can also say, when does this quadratic have a positive value? When is this quadratic above the y-axis? It will be above the y-axis, in this case, between the two roots. So the positive interval here will be 2 is less than x is less than 6. And that would be the complete chart to analyze this quadratic for you to complete these homework type problems today. Now, let's look at it in Desmos. Boop, boop, boop. Oh, I'm recording my desktop. That's good news. Okay, here we go, Desmos. And we're going to put in this quadratic. Negative 1 over 4x squared minus 2x. Plus 2x it was. Plus 2x minus 3. There it is. Yeah, that's our quadratic. Notice it had a vertex where we thought it did, 4, 1. It's increasing. Its value gets bigger as x gets bigger until you get to 4, at which point it starts decreasing. So that shows you the increasing interval is all x values up to 4. That's so strange. Why does it not show you? It's so weird. Look. It's so weird. I don't know why it's doing that. Anyway, how will I get it to show you there? Let's start a new Desmos window. If I show you here, if I copy and paste.
It's there now.
Now it's showing? Okay, good. All right, so now it's there. All right, great. So now you can see that that's so strange. Anyway, here, see how it, that's our quadratic. It has a vertex at 4, 1. Its roots are at 2, 0, and 6, 0, just like the quadratic formula told us. It's positive, meaning its y value is positive, anywhere between those two roots. If I go outside of those roots, it's negative. Has a negative y value. And it's increasing until it gets to the vertex, at which point it starts decreasing again. So those are all of the things that we discovered using the quadratic formula to analyze this little beast. All right, let's take a look at another beast. And I'm going to speed up my analyses a little bit. I'm gonna accelerate. So 2x squared minus 4x minus 1. Get some fresh paper down there. Start a fresh page. Zoom in a little bit to give myself lots of digital paper here. Okay, I'm going to get a nice fine pen, and we're going to launch ourselves into this one. 2x squared minus 4x minus 1. Oops. Get a little chart. A equals 2. B equals negative 4. C equals negative 1. We're going to use that to find the axis of symmetry first, and then find the vertex. So to find the axis of symmetry and vertex, I use negative b over 2a. That's going to give me the x value of the vertex, the axis of symmetry. So negative negative 4 is positive 4. And 2a is going to be 2 times 2. Oh, that's also 4. So that's equal to x. So 1 is equal to x. This is the axis of symmetry for this parabola. X is equal to 1. So now let's take that and find the y value of the vertex. I'm going to substitute in 1 for x wherever I see it. Notice to get that line, all I did was copy out the function here, but substitute in 1 for x wherever I saw it. So let's go. 2 times 1 squared is 2. Minus 4 times 1 is minus 4. So I'm at a grand total of minus 2. And then minus 1 gives me this is equal to, 2 minus 4 minus 1, which is equal to minus 3. Okay, that's the y value of the vertex. So that's the maximum or minimum value. In this case, is actually a minimum value. Y is equal to minus 3, and it's a minimum. I know it's a minimum because A is positive, so this parabola opens upwards. The vertex is therefore the lowest point, and then it starts growing again. So the vertex, we'll just put that together as a point, 1 minus 3, and I'm already preparing a visualization of this in my mind. Here is what you want to visualize too. Okay, you have your x and your y axes. You know that the vertex lied along the line x is equal to 1, and it was actually at minus 3. And then the parabola is going to open upwards. Let's find the y-intercept. Oh, there it is. It's just that easy to find the y-intercept. It's just that number when the parabola is in standard form. Because if I look at it and I say, well, the y-intercept, it happens when x is equal to 0. So if I put 0 in for x here and here, both of those terms are 0, and that's all I'm left with. So the y-intercept is at 0 minus 1. So now I know that I went from minus 3 up here to minus 1. That's going to be there. And this parabola is going to look something like this. Cool. Now let's find the x-intercepts. So my little chart of A is equal to 2, B is equal to minus 4, and C is equal to minus 1 is really going to be useful. So I'm going to copy it out down here. You don't need to copy it again, but I'm going to scroll my page, so I just want it on the page there. And now I'm going to use, to find the x-intercepts, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. All right, now follow the recipe and substitute carefully. This is going to be equal to negative negative 4. So negative negative 4, you can write it out this way, but just remember that that's just going to give me positive 4. Plus or minus the square root of negative 4 squared. This is me substituting in for b squared. Minus 4 times a, which is 2, times c, which is negative 1. Okay? All over 2 times a. So that's 2 times 2. Okay? Let's just substitute, and now let's solve. So negative negative 4, as I said, negative negative 4 is just positive 4. It just flips the sign again, back to positive. Divided by plus or minus the square root of negative 4 squared is positive 16. Negative 4 times negative 4 is negative times a negative makes a positive. 4 times 4 is 16. So there we go. And your calculator will tell you the same thing. And then we want to do negative 4 times 2 times negative 1. It's 3 things multiplying each other. Negative 1 just flips the sign. So we can think of negative 4 times negative 1 being positive 4. Then we're going to take positive 4 and multiply by 2. So that's 8. So we're going to be 16 plus 8 there. All over 2 times 2, which is 4. Remember when we found the x value of the vertex was 1? I can see here 4 plus or minus some stuff over 4. That would mean that the middle point is 1, or between the roots. And then the plus or minus happens on either side. So the anatomy of the quadratic formula is reflected in the shape of the quadratic. Okay, so let's carry on. 16 plus 8, well, we know that that's 4 plus or minus the square root of 24, all divided by 4. Okay, now let's do that. Okay, what's the square root of 24? Well, there's ways to simplify that, but it's going to be any predictions on the value of the square root of negative 24? What integer is it going to be really close to?
It's going to be closer to 5.
Yeah, it's going to be super close to 5 because the square root of 25 is exactly 5. 24 is a hair smaller than 25, so I'm expecting like, what do you think, 4.92?
Somewhere around there.
Yeah, cool. Good. Let's check. I don't happen to have the value memorized, but if I take 24, take the square root of it, oh, it's 4.89. We were so wrong, but actually it's really good to have a guess beforehand. That's going to train your ability to recognize these numbers in the future and to see when you make a calculator error. 4.9 is plenty good for our purposes. We don't need that much detail. Okay, so we're going to have, this is equal to 4 plus 4.9 over 4, or 4 minus 4.9 over 4. Because remember, we have to both add and subtract that thing, because the quadratic formula can give us two numbers. So those are the two numbers. So 4 plus 4.9 over 4 is 8.9 over 4. It's a little bit bigger than 2, a little bit smaller than 2.5. And then 4 minus 4.9 over 4 is equal to negative 0.9 over 4. Okay, that's a little bit less than a quarter, but negative. Actually, I should say a little more than a quarter, but negative. So if we want to, we want to find out exactly, well, not exactly what those are, but let's get a decimal expansion of those. 8.9 divided by 4, and that's going to be, as I said, a little bit more than 4 and less than 4 1/4. Sorry, 2 1/4. So that's equal to 2.2. That's fine. And then negative 0.9, but it's negative, and then I divide it by 4 equals, find the decimal, that's equal to negative 0.2. And that's going to be enough. That's going to be enough. So let's put those values into our chart. Our first x-intercept was 2.20, and our next x-intercept was negative 0.2, comma 0. Kind of ran out of space there. Anyhow, there's our x-intercepts. Now let's see. Where is this quadratic increasing? Let's take a look at our visualization. So I notice that because this quadratic is opening upwards, it's actually increasing after its vertex, not before its vertex. Over here, it's descending. It reaches the vertex and turns around, starts ascending up there. So the vertex was at 1. In this case, when x is bigger than 1, the quadratic is increasing. So that's its increasing interval. X is bigger than 1 is the increasing interval. And it has two positive intervals. Here's one of the roots. Here's the other root. No, I can't zoom in anymore. Yes, I can. So there's the two roots. If x is less than negative 0.2, that means like we have these values of x, then the quadratic is positive. If x is more than 2.2, that means if x is from there and over, it's also positive. So there we have two values of x that give us positive intervals. So we would have x is less than negative 0.2, or x is greater than 2.2 would be the two intervals that are positive in this case. For my last trick with this quadratic, I'm going to throw it into Desmos and confirm all the things we've just seen. 2x squared minus 3x, was it? Minus 1? Yeah, that was it there. So let's turn this one off. Let's take a look at this one. Oh, wait, well, no, I didn't have 2. It was 4, right? 4. Minus 4x minus 1, not minus 2x, 3x minus 1. Here we go. Yeah. Boop, 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 boop. There we go. All right, that was a quadratic we had. There's a vertex at 1 minus 3. It has an axis of symmetry on the line x is equal to 1. There's the axis of symmetry. It is decreasing as we... Good, we can see it. Yeah. It is where? Oh, can't see that point? Oh, that's weird. I'm showing you a point. It's decreasing all the way through here, and then it's increasing. So with x is greater than 1, the quadratic is increasing. And it's positive from here this way, and from here this way. Cool. Yeah, so those are all the things that we learned about it. Let's keep going. All right. I don't know if people have the patience to see yet another example. I don't think we need to see another example. I think you need to do some practice. So let's take a look at how we might apply these types of things in a more real world like situation. If I'm looking at this textbook problem, after a t, let me zoom it properly, get rid of my useless face. Okay, here we go. After a tee off, I want to zoom more, move this down. Come on. There we go. So I'll read it. After a tee off, a golf ball lands in a large sand trap 1 meter below the level of the green. So with problems like these, it's useful to have your blank paper ready and to draw a picture. Okay, here we go. That's good. That's good. Zoom level. Here. So the ball is going to start 1 meter below the green. So it's like down here, and the green is up here. So that's where we want to get this golf ball, okay? The golfer hits the golf ball out of the sand trap and onto the green. So I don't know if you've seen a ball move through the air before, but it tends to move like that in a parabola, okay? And the height of the golf ball can be approximated by the equation h is equal to negative 5t squared plus 15t minus 1. So here you go. This is our y-axis. The golf ball is hit right from the y-axis. The x-axis is actually the level of the green. And this starts at minus 1 below. That's the y-intercept there. So that's why I put the axes there. That's how I knew that the level of the green is the x-axis. I know that this is a quadratic that opens downwards because of the negative 5a value, and it crosses the y-axis in a rising motion at plus 15, slope of plus 15. That's from this b value. So that's how you use A, B, and C to visualize your quadratic. A tells you direction of opening and stretch factor. C tells you y-intercept. And B tells you slope at the y-axis. I know this is rising. It's not falling down that way. It's right. So that's how you visualize. See it in your mind, and it helps clarify what all the numbers mean. Let's keep going. All right, h represents the height from the green level in meters, and t is time in seconds. What do the h and t intercepts represent? So this is our h-axis, and this is our t-axis. So when we are at the h-intercept, that's down here, that means time is 0. That's the initial position. That's the meaning of that. The t-intercepts represent the points at which the golf ball is at the green level. That's when it's at the height of the green. So there's going to be one, and there's going to be another where it lands on the green. There's one where it passes the height of the green, and then it comes back down to the height of the green. So those are two different times. How long is the ball below the level of the green to the nearest hundredth of a second? Aha! Let's use the function here. H is equal to negative 5t squared plus 15t minus 1. And if I want to know how long this interval of time is until I get there, I need to know the value of that x-intercept. Oh, it's not an x-intercept now, it's a t-intercept. So I prepare my little chart. A is equal to negative 5. B is equal to 15. And C is equal to negative 1. Okay? And then I go ahead and apply the quadratic formula. And I sing the song. T in this case is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. All right. And now substitute in carefully and solve. Let's just zoom in here so we can substitute carefully and solve. T is equal to negative 15 plus or minus the square root of 15 squared, which is 225, Mr. Kujala's room, minus 4. We're 224, so we're 16 times 14. He's 15 times 15 over there. So minus 4 times a, which is negative 5, times c, which is negative 1. Okay? All divided by 2 times a, which is negative 5. All right? Let's evaluate. We should get 2 roots here. The discriminant should be positive because I know from my visualization I crossed the height of the green twice. I have to really duff it to not cross the height of the green. So let's go. All right. T is equal to negative 15 is negative 15. No change in that. Plus or minus means I'm going to add and subtract the results of this square root. 15 squared is as advertised, 225. Minus 4 times minus 5 times minus 1. I just count the negatives, find that there are 3, and know that gives me a negative number. Okay? And if it was 2, then it would be a positive number. If it was 1, it would be a negative number. If it was 19, it would be a negative number. Okay? This is an odd number of negatives. So 4 times 5 is 20. So this is negative 20. Okay? So it's 225 minus 20 all over 2 times negative 5 is negative 10. Okay? So one further simplification here. T is equal to negative 15 plus or minus the square root of 205. Positive number. I have 2 roots. Hurrah, that's great. So now, let's figure out what the square root of 205 is. I bet it's going to be a little bit less than 15 because I know 15 squared is 225. 14 squared is like 196. And this is about smack dab in the middle. So I'm going to guess like 14.4. Let's see what it is. Do these little tricks where you're guessing numbers before you calculate and you'll build your number sense. 14.3. Huh, I was so wrong. So let's go. So we have T is equal to either negative 15 plus 14.3 or negative 15 minus 14.3 all over negative 10. All over negative 10. Okay? Evaluate these two separately. So negative 15 plus 14.3 over negative 10 is equal to negative 0.7 over negative 10. That's a very small number. And it's positive because I'm negative divided by a negative is positive. Or 15 minus 14.3 is this is negative 29.3. Your calculator will tell you the same thing over negative 10. Are people okay that I skip going to my calculator and I just do the calculations in my head, but I know that either you'll do them in your head or you'll do them on a calculator and it will tell you the same thing? Okay, good. So I'm going to keep doing that. Negative 0.7 over negative 10 is equal to 0.07. And negative 29 over 3 is equal to 2.93. Okay, there's my 2x-intercepts. All right, and your calculator will tell you the same thing. And so let's use those x-intercepts to expand our picture up there. I know that it crosses here at 0.07 seconds and then lands on the green at 2.93 seconds. This is totally not practical. This is very like a golf shot. Go up, 2, 3, boom. He hits it way up in the air, I guess. Maybe that makes sense. Yeah. Okay. So now we've found how long it takes for the golf ball to rise to the height of the green. It only takes 0.07 seconds. Very fast. And it's up. And then it lands at nearly 3 seconds. So there we go. Let's continue the question. So that's the answer to B, is 0.07 seconds. How long is the ball above the level of the green to the nearest hundredth of a second? Okay, well, we know that it's above the level of the green here and here, wherever its height is positive. So we want to know how long is it above the green? Well, it's between 2.93 seconds and 0.07 seconds, it's above the level of the green. So we just use subtraction here to find that for 2.86 seconds, it's above the level of the green. This is 2.86 seconds long here. So that's how you would resolve that type of question. Again, it comes back to your ability to analyze a quadratic and find how long is it positive for. What's the value of t where it has a positive height. Related to the answer of part B and C, to the intervals for which the function is positive or negative, I just talked about that, and determine the interval for which the function is increasing or decreasing. Okay, so in order to find out how long this function is increasing or decreasing, I want to find the vertex. So I'm going to use this recipe here, but I'm just going to use negative b over 2a to find it. Negative b over 2a in this case happens to be negative 15 over negative 10, which is equal to 1.5. And so at 1.5 seconds, this ball reaches its vertex. Add that to our visualization. Here's 1.5 seconds here. You'll notice it's between the two roots, exactly between the two roots. That's 1.5 seconds. So this ball is rising for the first 1.5 seconds and then falling after 1.5 seconds. And that's that. Bye, Will. And so that's how you would analyze a situation like that with the golf shot. Now you know all kinds of information about that golf shot based on the quadratic formula. Any questions, hit me up by email if you're part of Team Learn at home. If you're part of Team Learn right here, bring me over to your desk with your hand or your hey, Mr. Jennings, give me a hand here. And thank you for showing up for your learning, everyone. Bye for now.